Have you ever wondered why planes can fly upside down? And what makes this feat possible? It seems to defy logic, but there's a fascinating explanation behind it. When you're on a flight, you might have caught a glimpse of a small plane performing aerial stunts, effortlessly gliding through the air with its wings pointing towards the ground. And here's the surprising part. Even large commercial planes are capable of flying upside down, albeit only for a short period. But what allows them to do so? The answer lies in the way planes generate lift, which is often misunderstood as only being possible when the wings are pointing upwards. However, lift is actually created by the movement of air over and under the curved surface of the wing, kind of like how a baseball player can make a ball curve by changing the airflow around it. So, even when a plane is flying upside down, its wings can still produce lift as long as the air is moving over them in the right way. And that's exactly what we're going to explore in more detail. So, if you've ever been curious about the aerodynamics behind inverted flight, you're in the right place. Be sure to subscribe for more explanations on how flying really works. Vocabulary, aerodynamics, inverted, commercial, curvature. What makes a plane able to fly upside down? Is it really just about the wing's special shape? Many people think the curved top and flat bottom of an airplane wing are what create lift, and that's partially true, but not the whole story. The key to understanding how planes can fly upside down lies in how lift is generated, and it's more about the way air moves over and under the wing. Think of it like a river flowing around a rock. The water speeds up as it goes over the rock and slows down as it goes behind it. Similarly, as air flows over the curved top of the wing, it speeds up and its pressure decreases, creating an upward force called lift. And here's the surprising part. It's not just the curvature that matters, but how the air flows over and under the wing, creating a difference in pressure that generates lift. This means that even if the plane is flying upside down, the wing can still produce lift, as long as the air is flowing over and under it in the right way. So, it's not just about the shape of the wing, but about how the air interacts with it. And that's what makes inverted flight possible. Now that we've got a better understanding of lift, let's dive deeper into how planes use it to fly upside down. And it's more fascinating than you might think. Vocabulary, aerodynamics, curvature, pressure, lift. What happens when a plane flies upside down? Does the wing still produce lift, or does it just fall out of the sky? To understand this, let's talk about the angle at which the wing meets the oncoming air, known as the angle of attack. Think of it like throwing a paper airplane. If you throw it gently, it glides smoothly, but if you throw it too steeply, it stalls and falls. The same thing happens with a plane's wing. If the angle of attack is too high, the air can't flow smoothly over it, and lift is lost. But here's the surprising part. Even when a plane is inverted, the wing can still produce lift as long as it's moving forward and the air is flowing over it in the right way. It's all about the angle of attack. As long as the wing is moving through the air at shallow enough angle, the air will still flow over and under it, creating the difference in pressure that we call lift. And that's why, with the right conditions, a plane can indeed fly upside down. The wing is still producing lift, even though it's inverted. So, the key to flying upside down isn't about defying gravity, but about controlling the angle of attack, and that's what makes it possible. Vocabulary, aerodynamics, angle, attack, lift. What happens when a plane flies upside down? Do the usual rules of aerodynamics still apply? When a plane is inverted, the forces of lift and weight are essentially flipped. They're in opposite directions to what we're used to, which can seem counterintuitive. But here's the interesting part. The plane's control surfaces, like ailerons and elevators, can still be used to control the aircraft. They just need to be used a bit differently. Think of it like riding a bike. When you're riding uphill, you need to adjust how you steer and balance to compensate for the change in gravity. And it's similar with a plane flying upside down. The ailerons, which are like the bike's handlebars, can still be used to roll the plane, and the elevators, which are like the bike's brakes, can still be used to pitch the nose of the plane up or down. However, pilots must carefully manage these forces to maintain stable flight, as the balance between lift and weight is much more delicate when the plane is inverted. It's a bit like a high-wire act, where the pilot needs to make constant adjustments to keep the plane flying smoothly. And that's what makes flying upside down so challenging, yet so impressive. So, to answer our question, the usual rules of aerodynamics do still apply, but they need to be applied with a lot of skill and finesse when flying upside down. Want to learn more about the art of flying and how planes can perform incredible maneuvers? Vocabulary: aerodynamics, ailerons, elevators, counterintuitive. What makes it possible for a pilot to deliberately fly a plane upside down? And how do they even learn to do such a thing? The answer lies in rigorous and highly specialized training. Think of it like learning to drive a car, but instead of just knowing how to steer and brake, you need to understand the intricate mechanics of the engine and the physics of the road. In the case of flying, pilots must develop a deep understanding of aerodynamics, including how the wings produce lift and how the plane responds to different control inputs. And when it comes to flying upside down, they need to be able to recognize and respond to the unique conditions of inverted flight, where the usual rules of upright flying no longer apply. It's an incredibly rare and complex maneuver, and one that requires an enormous amount of practice and dedication to master. Pilots who undertake this kind of training are essentially learning to think on their feet, to anticipate and react to the unexpected, and to trust their instincts and training to get them through even the most challenging situations. And here's the part most people don't know. Even with all this training, flying a plane upside down is still an extremely rare occurrence, usually only done by highly experienced pilots in very specific contexts, such as air shows or military operations. So, to answer our original question, planes can indeed fly upside down, but it takes a huge amount of skill, knowledge, and practice to make it happen safely. Vocabulary: aerodynamics, maneuver, inverted, dedication, instincts. So, why can planes fly upside down? It all comes down to the remarkable properties of lift and the careful control of aerodynamic forces. Think of it like a highly skilled balancing act, where the pilot adjusts the wings and tail to keep the plane stable, even when it's inverted. The wing is able to produce lift in any direction, not just upwards, because lift is created by the difference in air pressure above and below the wing, and that difference can be maintained even when the wing is pointed downwards. And here's the surprising part. The plane's instruments and controls are designed to work just as well when the plane is upside down as they do when it's right side up. This means the pilot can make the necessary adjustments to keep the plane flying smoothly, even in unusual attitudes. It's an incredibly rare occurrence, but when it does happen, it's a testament to the pilot's skill and the plane's impressive capabilities. So, to answer the question, planes can fly upside down because of the combination of lift, control, and pilot training. If you're curious about more aviation mysteries and insider knowledge, be sure to subscribe for regular explanations that make flying fascinating and reassuring. If you'll never look at a plane the same way, you know what to do. Vocabulary: aerodynamic, invert, instrument, altitude, capabilities.